Good morning, everyone. Today I'm going to talk about transfer learning, an important concept in deep learning that helps us train smarter, faster, and more effectively. So, first, let's understand why we need transfer learning. Normally, training a deep learning model from scratch requires a lot of data and computing power. But if our data set is small, and that's where transfer learning comes in. Transfer learning allows us to reuse a model that's already been trained on large datasets for a new but relatable task. It helps the new model learn faster, perform better, and use fewer resources. For example, you can take RESTnet or MobileNet, which are pre-trained models on massive data like ImageNet. Instead of starting from zero, we can fine-tune these models on our own datasets. A great example is YOLO, a pre-trained model detection model. Rather than training from scratch, we can use YOLO pre-trained features and fine-tune it on our customized data. This gives us higher accuracy, uh, computational resource. Now let's look at what transfer learning actually does. It all about reusable knowledge. When a model has already learned patterns, edges, and textures from one task, those features can be useful for another task too. This means we can get good results even with a limited amount of data. Transfer learning also reduces the chances of overfitting because the model already knows general patterns rather than memorizing new data. In short, it saves time, accuracy, and conserves computational resources. Uh, the working mechanism, here's how the process actually works. The first step is we start with taken pre-trained model. The model has already learned from a large data set like ImageNet capturing general visualized features. Then we use a base model. The layers of this base model learn from simple edges in early layers to complex patterns in deeper layers. Then the third step is to select transfer layers. These are the layers that contain reusable general information that works for both the old and the new task as well. We adjust or retain only selected layers to make the model adapt to our new dataset. If the new dataset is small or similar to the original one, we fine tune fewer layers. If it's larger or very different, we fine tune more layers. This process allows the model to retain useful knowledge while adapting to new tasks quickly and effectively. Let's see now that the transfer learning isn't perfect. It does come with challenges. The first is overfitting risk. If we fine tune too much on a small data set, the model might overfit. The second is model selection. Choosing the wrong pre-trained model can reduce performance. If your task requires classification of furniture and you choose a model which is not related to it, uh, this can reduce the performance. The third is computational cost. Fine-tuning deep learning models can still be expensive in terms of time and GPU usage. The third is domain mismatch. If the new task is too different from the original, the transfer won't work well. The third is data imbalance. Uneven data distribution can affect accuracy and stability. So let's see an example. If a model is trained on ImageNet, which has objects like cars or animals, and which we used in our project, and we fine tune it to detect plant disease, it might struggle because the two domains are different. That's called domain mismatch. So from this we can conclude that transfer learning is a very powerful and effective approach in deep learning. It reuses knowledge from pre-trained models, saving time, reducing the need for huge datasets, and improving accuracy. By fine-tuning the right layers, we can quickly adapt a model to a new problem while keeping its valuable learned features. Even though it has challenges like domain mismatch or overfitting, its benefits far outweigh the drawbacks. That's why transfer learning is widely used today in applications such as image classification, object detection, and natural language processing. Thank you.